Okay, guys. So welcome to this module. This is the first lecture. I believe it is even the first lecture of the year because yesterday you had only labs. But even if you had some lectures, then you got the experience in terms how the whole process is going to go on. I'll try to speak clearly. The lecture is going to be recorded, and as I said again, is going to be uploaded in the module website. So you have not missed anything. You can always go back to the record and listen to the lecture. This is very important, especially you will be having tests later on. So yeah, you can just prepare popcorn, coffee or Pepsi, and then listen to those records. Okay, it's going to be video records, even better than watching a movie. Okay, so the first lecture, it is Introduction and Data Representation 1. We said that in this module, you will be studying about the hardware and the operating system. So we will go into details about each component of the machine, understand the components of the machine, the CPU, the memory, the input-output devices, the ports you've got in there, the buses where we said that we've got these lines that they carry data, addresses, control commands. So we will go into details into understanding the hardware. Then we will explain the software, the operating system that works in order to control and manage this hardware. So I'm the module leader of this module. This is my office room, and this is my email address. If you have any issue, you always get back to me. Mr. Gelly is another person who will be teaching the labs. So for my case, I'll be teaching the Monday morning labs and the lectures, while Mr. Gelly, you will see him for the labs. The late labs, which is from 4 to 6 and 6 to 8. And this is his email address if you need to communicate with him. You've got a bunch of SLAs for the morning session, Monday morning session, and even for the late sessions. If you need any help, you can always get back to them. I think they said that they will create a WhatsApp group, so you can always join that WhatsApp group and ask your questions. This is what we do also every year. We create drop-in sessions for students. This is a common session for all the students if they have questions, if they have late stops, if they are struggling with work, we give them the help, but still we have not discussed as a team member about those drop-in sessions. We don't know when it's going to take place, whether it's going to be virtual, whether it's going to be in the campus. We have not agreed yet, but definitely you will have some drop-in sessions for all modules. The goal of the course, as I mentioned earlier, you will understand the fundamentals of the computer hardware, the main components of the computer hardware, the monitor, the keyboard, the RAM, the motherboard, the CPU, the power supply, the hard disk, mouse, all those little components, hardware components. And then you will understand the fundamental of the operating system, how to control all those hardwares and manage them and make them work the way that they are meant to be working. These are the textbooks for this module. So the first book, what we are using, it is for the hardware. We've got like all the lecture slides, they have been taken from that book. So this is for the hardware part, which is the first 12 weeks. The second part, it is the operating system. And if you go back to this book, you will see that we have taken the operating system part, which is the next 12 weeks from this book. So if you want to expand further in the information, you can always go back to those textbooks. But I can assure you the slides you've got are more than enough because we have summarized the chapters of the books to be presented in 25 slides, 20 slides, or even not less than 20 slides, like the maximum 20 slides. The class details, you will be having 1 hour lecture and 2 hours lab every week. And this module is gonna run over 24 weeks. All the details you need, all the module material, whatever you need, the assessments, the submission of the assessments, you can find them in the module website in your My Uni Hub. So you will find there the module handbook that has all the details about the dates when you need to submit, whenever you've got an assessment, the lecture notes, the labs, any other resources where, for example, the submission links, the tests that you might need to attempt and all of that. And in terms of the office hours, you email me anytime, and then we could always arrange a meeting, whether it's going to be over Zoom or if it is urgent. Well, we have not experienced that yet. We might have a face-to-face meeting, but I don't think we are allowed to have it in the office. So we can have it like maybe in the lab room or in the college building, something like that. But mostly it's going to be a virtual one. I'll send you a Zoom link and we can have the meeting. The assessments in this module, you have 3 main assessments. The first one, you've got three tests, and they are going to be based on your lecture. So each test is 10%, and the dates of the tests, the first test is going to take a place in week 8, then you've got the second one, week 14 and week 22. Then you've got SOPs, and we said these are lab tasks that you need to complete every week during the lab session, and it is worth 40%. And the last assessment, it is the project. You've got 3 projects in there, and each project, it is 10%. And those projects are group projects, so you will be working in pairs, or you will be working in a group of 3. It depends if you want to have a bigger group. And these are the submission dates of the projects: week 9, 15, and week 23. Okay, so that was a small introduction about the module. Now we will go into more details about what you will be doing in this module. So what is computer architecture? Computer architecture, it is actually the study of the hardware, because this module, the title of the module, it is computer architecture and operating systems. So what is computer architecture? The first part, it is studying the hardware of the module, of the machine itself. So why do we study computer architecture? Because we need to understand what the computer is, because we said that we need to understand this monitor. We need, like, it's not only pressing on the buttons here, playing videos, or for example typing to write an assignment. No, you need to understand how this machine works, what is inside the CPU, what are the main components of this machine that actually control the whole machine, how this machine is being designed, understand maybe the assembly language of the machine that is actually being used, the machine language, because we said that the machine itself, it does not understand the human language. Don't expect that when you type in English an assignment that the machine will understand it. No, there is a converter inside in there that's going to convert whatever letter, whatever character, whatever symbol you use there into a machine language, which is zeros and ones. And this is how the machine is going to understand it. Even the commands you give, for example, I want to print the letter H. I want, for example, to raise the volume and all of that. All of these instructions, these commands will be converted to zeros and ones. This is how the machine understands. Also, for example, this module will keep you alert and aware about the new computer architecture designs. Do we have like machines only with one CPU? Do we have machines with multi-CPUs? What are the differences between the two? All of this we will understand it in this module. So what you will be studying in terms of the computer architecture in this module, you will study the data representation. How do we represent the data? The logic gates. I'm not sure like if you studied this in your A level or in your high school where you've got these ICs, the small ones, we call them logic gates, for example, AND, NAND, or XOR, where you have them on a board and then you have these little connections, the wires, in order to perform a certain task and get an output. Maybe in order to be able to read the output, you have a LED, a light. If that LED worked, light up, that means you've got an output. The output is 1. If it did not light up, that means it's 0. You can have more than one LED, and some of them gonna light up, some of them they are not gonna light up, and if they light up, this is 1, not zeros. We will do all of that. We will experience all of that. Also, you will be studying the combinatorial and sequential logic designs. Now you will tell me, why do we need to study logic gates and all of that? Because we've got in the machine itself, we've got registers. These are very important components where the CPU access in order to execute instructions. Those registers themselves, they are made of the logic gates. So we need to understand the essential components that actually make that important asset within the machine. We will also study the CPU, the instructions, the different languages, assembly language, machine language, how to convert between the different languages. We will study the primary and the secondary memory. We have RAM, ROM, we have secondary memory, we have secondary storages, all of that we will study it. We will study about the control unit and microprogramming, more details about computer architecture, input-output devices, memory units, and all that. Data. What do you mean by data? What I mean by data, information in your machine. It's not only information. The data itself, it can take different shapes. We don't have only written data. We have, for example, images. We consider them as data. We have instructions. These are data. We have videos. We have records. We have files. We have folders. All of these are data, or you can call them information. The data themselves, they can be represented in different ways. They can be represented in bits. They can be represented in bytes, and they can be represented in words. And we will know the difference between each one of them. Bits, it's 0 or 1. You don't have that many options. Bytes means 8 bits. Words are, I think, 16 bits, and so on. We will explain all of that further in the following slides. Don't panic, it's not difficult at all. Also, as I said, in terms of data, we don't have only, like, for example, one type of data. We've got so many different types of data. You've got even characters, emojis, we consider them as data. You've got integers. You've got, for example, images. You've got so many different types of data. The data themselves, we have binary, we have octal, we've got hexadecimal. All of these data, the way that you represent them, they can be represented in different ways, and all of these going to be explained to you in the following lectures. Even the representation of negative number, when you type, for example, -1, the machine won't understand what is -1. No, it's going to convert it to zeros and ones, and the machine will understand, oh, this is -1, this is a negative number. You, as a student who's studying this module, need to understand how the machine reads those three integers. Also, how to add the binary integers, how to subtract them, how to multiply them, how to divide them, how to represent real numbers. All of this, you will understand it clearly in this module. So it's not difficult. And it's not only you will understand it and be able to do it, you will program it in C as well. How the data are presented in a computer, I've already mentioned that the computer does not understand any other language. The only language that the computer understands, it is the binary, which is the machine language. The binary or the machine language, it is represented into two values, 0 and 1. 1 means there is it's true, 0 means false, or it could be, for example, voltage, no voltage. So there are so many different expressions for what 0 and 1 means. Even in the memory, if it is 0, that means that memory location is available, it's free. If it is 1, that means that memory location is occupied. There is already some data in there. So this is how the data is being represented. This is a sequence of data. So as I said, this is our presentation. If you convert this, this is 65, number 65. So the machine won't understand this is 65, but it has to convert it to this shape to understand that 1000001, this is the number 65. And we will teach you how to do the conversion. So imagine if you have a switch. So this is switch is on and the rest are all zeros and this is on. So this is how it works. This is if you want to imagine it as a switch, but technically within the machine, you will see it like that, 1000001. So how does the computer know what any particular sequence means in this case? Well, the computer has been programmed in this way. The computer itself does not know, but we human know, and we have programmed the computer to function in this way. Because why we have done it this way? Why we didn't do it in English? Let us make the computer understand English, that's easier. Well, in this case, that means each country, it needs to have their own invented computers because we've got so many different languages. So that means if we have a computer in English, it's going to work here in England and it's going to work here, work in US. But if you take the same machine to, let us say, any Arab country, it's not going to work there. So that's not right. It's not going to work this way. You cannot have a machine based on your own language. So they thought of, okay, why don't we have a common language, which is the machine language? This is the language that machine itself understands. Then we can have our own language, the human language, the different languages, but the machine understands how to translate each language into the machine language. This is to not have a confusion. And this is why we have well-known brands for the people who actually build the machine. And then you can install any sort of language that you've got on it, but the machine language is fixed for all the machines. So yeah, as we said, that number that you've already seen, the binary number, which is this one, it represents 65 in decimal. It's not only that, it represents A in ASCII code, and I explained to you what I mean by that, or it could be anything else. But why so it could represent two different things at the same time. But how the machine would understand that I mean a number, I don't mean a letter, or I mean a letter, not a number, or I mean something else? Well, the machine does not understand. You understand that here I want to print a letter, here I want to print a number, and the machine is going to translate it. And again, as I said, you have programmed the machine to function this way. So obviously, if you are typing an assignment, words, well, while you are typing, I've pressed on letter A. So that means you mean letter A by this. Or if I press on number 65, that means the machine will know that you want number 65. It's a machine that does not know, but you know, based on what you are pressing on the keyboard, the machine is going to translate it to the machine language and the way that it does understand it. Computer memory. Computer memory is a very essential component because the computer does not only do commands, the computer itself, it also saves data, because where all those files, pictures, data, instructions are being saved. So this is, we will understand it and explain it in this module. But I want you to imagine the memory location is like a switchboard. Like for example, you have a switchboard, and inside the switchboards in there, you've got locations. On those locations, they could be occupied with data, or they could be empty, ready to be occupied with another data. And each location in there, it must have an address and a value. The address to indicate, oh, address 1, it's there. Okay, what is the value inside address 1? It could be occupied with data, or it could be 0. There is actually no data in there, so it is ready to be occupied by any data. So it's a free. Okay. And again, for the memory, we will be having how many lectures? More than one lecture to explain the memory. How does it look like? The shape of the memory, the size of the memory, the main components of the memory, and then the operating system, how the operating system manages the memory. I've already mentioned that at the beginning. So in the memory, if you want to represent the data, they can be represented in bits, nibbles, or bytes. Bits, as I mentioned earlier, zeros or ones. You don't have that many options, whether it is 0 or 1. Nibble, the nibble is 4 bits. So it could be 1001, 0010. So it's 4 bits, no more than that. But they saw that the most convenient way to represent data in the memory, it is through bytes. So 1 byte, it is 8 bits, or we can say 2 nibbles. Why I'm repeating this more than a time? Because you will see this question in the test. Maybe you will be having a test asking you how many bits in a nibble, or how many bits in a byte. So, and then I'm gonna give you multiple choices. Are there 2 bits, 4 bits, 6 bits, or 8 bits? And you need to choose the right answer. Also, we have a word of memory. A word of memory, it means you have 8 byte, you have 8 bits, 8 bits. So in total, it is 16 bits. What is the word? The word, actually, we do use it in order to represent the size of the registers of the machine. So let us say, for example, when I say that, what is the type of your machine? You will tell me it is 64 bits. What does it mean? What does it mean 32 bits? What is 64 bits? From the manufacturer. Also, when you want to download some programs, it tells you that if you have a machine of 64 bits, you can download this program. If your machine is this bits, you can download the other program, the other version of the program. 64 bits, it means that this is the size of the registers that you've got in your machine. The registers, we said that these are the quick memory access that the CPU accesses in order to complete instructions. So having 64 bits means that you are having 64 registers. So that means you are having a powerful machine. The CPU got more options to save instructions quickly, access the instructions quickly and all of that. This is what we mean by 64 bits. It's not the memory size. The 64 bits are the register size, and you will explain to you what is the difference between the registers and the main memory or the memory that you have. For the CPU itself, in order to execute instructions, it does not have time every time to be wasted and go to the memory to get the information that actually are needed in order to execute instructions. No. For example, if I have a mathematical operation and the CPU wants to execute that mathematical operation and needs, for example, the addition operation, it does not have time to go request it from the main memory, carry the data, find the address, carry the data from the main memory on the data bus, retrieve it to the CPU, execute, and then save the output in there. It's just going to take ages. But we've got these registers, they have been placed very close to the CPU. And then whenever the CPU needs an instruction to be executed, an operation to be executed, input, output, needs input to be executed, save an output, immediately it accesses the register straightforward in less than milliseconds, and then finish the execution. So you might say that, does the register have all the information needed for the instructions? No, they don't have all the information needed for the instructions. So in this case, the information needs to be fetched and grabbed from the main memory into the registers for execution. But let us imagine the registers like a cache memory, like something quick to be accessed. Rather than going to the far distance, you've got a close distance of information that it can be accessed quickly. And here you've got different type of computers. And here the different number of registers you've got on each computer. Now, a character. We said that if you want to represent something in the computer, we are not only talking about representing numbers, integers, real numbers, negative numbers. No, we've got characters. And those characters, they could be, for example, uppercase letters, they could be lowercase letter, they could be single digits, special characters, like, for example, those different signs. You might have emojis, you might have so many different characters, expressions that we are actually using within the machine. So how would the machine would understand all of that? So they came up with a table. They came up with something, they called it the ASCII code, which we will explain in the following, which I have an example of it in the following slide. So what do you mean by ASCII code? This code has been introduced by an American institution, and there they've introduced a collection of integers, characters or symbols, uppercase characters. Like, for example, when you press a capital, uppercase is completely different when you press on a lowercase. The way that, for example, this is how the keyboard will understand, like, now I want to print A with uppercase, or I want to print A with lowercase. So the representation, the way that's going to be represented is different. So all of that has been included in the ASCII code. And there are so many different other characters, but ASCII code is the most common one. But you will see later, it's not the best one. And I'll tell you why in the following slides. So yeah, as I've already mentioned, you have characters, a uppercase, a lowercase. The way that they've been represented in that long number is different. Now, we said that if you want to read this long number, you can divide it into 8 bits every time, because we said that the bytes are the most convenient to represent the data and to save the data in the memory. So once you divide it into 8 every time, we will teach you in the following slides how to convert this binary into real number, actual numbers. All of that we will explain it. Don't panic if you don't understand what is in there, because all of this is going to be explained in the following slides. In the following lectures. Also, why it is important to understand zeros and ones. Let us say, for example, if I have letter A and I've printed it on my monitor. If you bring the monitor very close to you, you will see the monitor consists of small dots, which we call them pixels. Now, why letter A has been formatted this way? If you make it very close and makes it bigger and bigger and bigger, you will see that there are some of the pixels, some of the dots are actually colored and some of them are not. If they are colored, that means it is one. So if it is colored, that means it's occupied, and this is why you see it in this shape. If it is not colored, that means it is zero. And again, you can see that the machine, how it translates things. Like even if you want to print something, it's going to translate it to zeros and ones. So as I said, your monitor consists of pixels. And yeah, if you make it closer to your eyes, you will see that there are these little squares in there. We call them pixels. If they are colored, means one. If not colored, means zero. And this is why you have A in this shape. Okay, and this is how it's going to look like. Got these small pixels. So here you've got 1, 1, 1, 1, 1, and here you've got 1, 1, 1, 1, 1, and whatever in white, this is 0. Okay, and this is how to represent A. Imagine how many zeros and ones just to print that small letter on your machine. Okay. Now, so ASCII code character, as I've mentioned earlier, when you press on a uppercase or a lowercase, the representation of them in the machine language or in decimal, we call it decimal, completely different. And this is how the machine differentiates that, oh, this is uppercase, this is lowercase, or for example, this is number 9, this is the character of greater than or lower than or equal or plus or division or whatever. So what they said, how the machine would differentiate in terms of that, they were like, okay, this ASCII code actually has been found for Roman alphabets, like for English, purely for English. And this is how it looks like. This is ASCII code. You can see, for example, if I want to represent letter A, where is A? This is A. Do you see? This is uppercase A, and it is 65 in decimal. You can convert it to binary, and it's going to give you this number in binary. Now, for example, if I go to A small letter, this is A small letter, this is in decimal, and this can be converted to binary. The numbers going to be different. So this is different than this one. And even in binary is going to be different. And this is how the machine will understand, oh, this is uppercase, this is lowercase. And also you've got other special characters in there. So you can see mainly this is for English. Don't worry about the hexadecimal. We will teach you later on how to convert to hexadecimal. Also, you've got for the special characters, addition, multiplication, all of that, you've got it in there. And yeah, so the size of the ASCII code is 128. So what you have here, you've got 128 numbers and characters. This is the size of the ASCII code. And the way that it has been organized, it is in a non-sequence. So for example, letter A, uppercase A, is before Z, uppercase Z, but the A small is after the capital Z. Let me explain what I mean. So the uppercase A, it is before the uppercase Z, but the small letter A is actually after this one. So you finish for all upper cases and then you start with the lower cases. It has to be in this sequence. Why it has to be in this sequence? Because the numbers are in sequence. We don't want to mess it up. We've got other character representations, so we don't only use ASCII code. There is these old ones as well. You've got the EB CIDIC code. You've got Abudot. You've got PCD. You've got 80 colon. All of these are similar to the ASCII code. These are old codes that actually have been used in order to represent the data before the appearance of the ASCII code. And this is how they look like. This is an example of each one of them. You can see that they've got different characters in there, how to represent them. This is also another representation. This is just an example. I'm not expecting you guys to understand all of this. And then you've got this one is another example. However, you can see that with ASCII code, you've got only 128 options. And even with this one, you don't have that many options in terms of representing characters, because I'm sure that you've got other characters in there. You've got, and also we don't speak only English. Let us see that, for example, I want to type in Arabic in my keyboard, or I want to type in any other language. Would you think that the ASCII code will be enough? We don't have any other letters in there. We've got only English, numbers, and those characters that we know. But we've got other things in the machine itself. We've got emojis, we've got different languages, we've got different characters. So they thought of ASCII code is not enough. And this is why they came up with Unicode. Unicode, it's a non-Roman character. It includes so many different languages: Greek, Arabic, Chinese, Hebrew, Japanese, Thai, any language that comes to your head, Urdu. Because you need to have a common code. It's not a code that, because not all of us can speak English. Well, the machine needs to understand there are so many different languages, so many different characters. So they were like, okay, why don't we come with a new table, with a new code? They came up with the Unicode, and the variety in that code, it has options of 136,690 characters. You can see that one was 128. This one, it has more options. And here you've got, it includes all the different alphabetics with different languages, characters. And there is an example, by the way. This is not the whole thing. You can see that even here, we've got different characters in here, and it gives you the representation of each one of them. You've got letters in different languages. You've got emojis. You've got different characters. All of them, they've summarized them in this number of characters. And they said we will be using ASCII code for that. Okay, well, yeah, I'll answer your question, Frederick, but I think I finished, yeah, the lecture. Just I'm gonna finish it, and then I'll answer your question. I'll open the unmute button so you can ask questions. This is just to think about it at home. It's not a homework, but you may think about it. How could we translate this to a machine language? So you go to the ASCII code, you check H, which number is in front of H, which number is in front of E, which number is in front of L. So for example, if we go to the ASCII code, which is the easier one, so we have hello. So hello, it is lowercase. So you go to H, oh, this is the number in front of H. and then we've got E. This is the number in front of E. And then this is the number in front of L. We've got two L's. So again, rewrite it again. And then we've got O, and this is the number in front of O. So you have the list of numbers in there, and then you convert those numbers into binary. As I said, it's not a homework, but yeah, you might play around with it, have fun with it, because next week I'm going to explain to you how to convert those numbers, decimal numbers, into binary. And I think we have finished the lecture. So what I'm going to do, I'm just going to stop recording, and then I may answer your question.